In this video, we're going to calculate the alpha and beta of a stock in Python. First of all, what is alpha and beta? Both of these Greeks are two key metrics used in finance to measure the performance and risk characteristics of a stock or an investment portfolio. They are part of the capital asset pricing model, CAPM, and are widely used in risk management and performance evaluations. First off, beta. The definition of beta is measures a stock's volatility in relation to the overall market. It indicates how much the stock price moves compared to the market itself. So if we have a beta that's equal to 1, the stock's price moves with the market. If the beta is greater than 1, the stock is more volatile than the market. If the market goes up or down by 1%, the stock is expected to go up or down by more than 1%, respectively. Beta less than 1, the stock is less volatile than the market. So again, if the market goes up or down by 1%, the stock is expected to go up or down by less than 1%, respectively. And then beta equal to 0, the stock's price is uncorrelated with the market. And then finally, beta less than 0, the stock moves in the opposite direction of the market, which is rare. So the use case of beta is to assess the risk of a stock relative to the market. This is crucial for portfolio diversification and risk management. Next, we have alpha. The definition of alpha is measures the performance of a stock or portfolio relative to a benchmark index, considering the stock's beta. It represents the excess return of the stock or portfolio over the expected return given its beta. The formula for alpha is equal to the return of the investment minus, in parentheses, the risk-free rate plus the beta of the investment, and then the return of the market minus risk-free rate. The interpretation for alpha is if alpha is greater than 0, the investment has outperformed the market after adjusting for its risk, positive alpha. Alpha that's less than 0, the investment has underperformed the market after adjusting for its risk, negative alpha. Alpha equals 0, the investment has performed as expected based on its beta. In other words, it indicates that the stock has neither outperformed nor underperformed the market after adjusting for its systemic risk. The use case of alpha is to use it to evaluate the performance of an investment compared to a market benchmark. It helps investors identify whether an investment manager has added value through active management. We are now in the Jupyter Notebook, so let's check out how to calculate alpha and beta for a stock in Python. First off, we're going to import the libraries that are going to help us today, such as pandas. We're also going to import NumPy, Yahoo Finance. I'm going to use Y Finance. And then finally, to visualize our relationship between the benchmark and the stock that we're analyzing, I'm going to import matplotlib. So first, gather historic price data. Alpha and beta of a stock are measurements related to the benchmark like the S&P 500. So let's say we want to analyze Apple stock and compare it to a popular benchmark. So in our example, we're going to use the S&P 500. So if I typed upper caret GSPC, This is going to give me the S&P 500 from Yahoo Finance. Next, we would need a start and end date of our analysis. So let's say we want to look back uh, like 4 years or so. So we could start off with 2020, and then we'll have an end date. So I'll just do today's date. For me, it's May 15th. And then finally, we're going to actually fetch our data from Yahoo Finance. So I'm going to use our library YF, download the stock symbol, and then the start date and our end date. And then I'm going to do the same thing except for the benchmark. So I'm just going to copy this line here. And then all I have to do is change stock symbol to benchmark symbol. Okay. So I'm just going to print the stock data frame. And this looks great, right? We have the open, high, low, and close, adjusted close and volume for the time frame that we specified. So that's perfect. So now we'd want to calculate the daily percent return for both the benchmark and the stock that we're analyzing, which is Apple. So in order to do that, we could create a new column, or rather, we're going to create a array based on the adjusted close column. So we're going to do stock data adjusted close percent change dot drop NA. Since we're comparing two dates, we're going to have one row that's going to become NA. So we need to drop it from our analysis. And then the benchmark, we're going to perform the same exact returns calculation. So I'm going to do a copy paste. And instead of stock data, I could just go ahead and say benchmark data. Okay. So I'm going to hit enter, and it doesn't like that for some reason. Adjusted close key error. Oh, I got you. It's just the space. There's no underscore. So I called it by the wrong name. Okay. So here we have stock returns and benchmark returns. Let's see what stock returns look like. So this is a data type float, and we have the date and the percent change in adjusted close. So this works perfectly for us. And we did not add it into the original data frame. So if I were to type stock data again, it's not a new column in our data frame. Okay, so calculate beta and alpha. Sorry, before we do that, we actually would want to merge the two together in order to calculate beta and alpha. We want to merge the returns of the stock and the benchmark into one data frame. So I'm going to call my data frame returns, and I'm going to say pandas merge. I want the stock return and the benchmark returns on date and then these suffixes as stock and benchmark. That way we know which return is which, and then we're merging based on the date so that our data stays nice and ordered. Okay, so then I'm going to print out what that data frame looks like. So now we have a new column, two new columns in a new data frame, adjusted close stock, adjusted close benchmark, percent changes. Okay, perfect. So now we can calculate the beta and the alpha. So our X is going to be the benchmark. So I want to call back the data frame we just made, adjusted close for the benchmark. And then the Y is our returns of the adjusted close stock. After that, we want to add a constant because we're going to be running a regression against the Y. So we're going to go to numpy vstack. Numpy is going to allow us to add that constant. Okay, so forgot to add the closed bracket there. So what does this look like? This is going to give us that numpy array. We have our return of the benchmark, and then we have a constant 1 to allow us to run a regression analysis. Now that we have that, we could perform the linear regression to get beta and alpha. This is going to be numpy dot linear regression okay. And then finally, I'm just going to make the print statement a bit prettier to look at with the help of F string here. All right, and then I'm going to click enter. And then here you go. So for Apple, when we compare it to the S&P 500, the beta sits at 1.18 and the alpha is essentially 0. So what does that mean for Apple? In this case, we see that the beta of Apple is near 1, but it's a bit greater. So we could say that Apple is a stock that's more volatile compared to the market. Even with higher volatility, alpha is at basically 0. So that means Apple has performed as expected based on its beta. So that means Apple is a stock that neither outperformed nor underperformed the market, adjusting for its systematic risk. So this showcases Apple continuously following the benchmark. However, along the way, it's more volatile, slightly more volatile. So why don't we visualize what we just calculated? What does the linear regression look like comparing the benchmark to our stock of choice? So here we could leverage matplotlib and say plt dot figure. We're going to create a new plot, and we would want to use a scatter plot so that we could see all of the data points in our analysis. So we could label this as data points. Data points basically meaning the average close percent change of both the benchmark and Apple for each single day in our analysis. And the color, let's just say blue. So let's just see what this looks like so far. Okay, great. So here we have the benchmark returns, and then here we have Apple's returns on the y-axis. So we could see that there's a positive relationship between the benchmark's performance percent change and then Apple's performance percent change. And for a linear regression, you would want to see some correlation between the two. So that works out great for us. Now let's showcase the regression line. We can do this by doing beta times x plus alpha. And then plt dot plot the regression line onto our chart overlaying above our data points. I'm going to give this a label. All right. So let's see what this looks like now. And there you go. So now we have the actual linear regression line over our positive relationship between the benchmark and Apple. So now we could go further and make this a little bit more pretty to look at and say X label benchmark returns plt.y label stock returns. The title, we could just say linear regression of our stock of choice. All right, and there you go. So we have a regression line where the beta is 1.19, the alpha is 0, and our data points are in blue. So where does the beta actually come from in our analysis? Basically, the beta is the coefficient calculated in the linear regression line between the stock's return and the beta, or excuse me, and the benchmark market return. So the increase in the benchmark return is associated with however much increase in the stock. Since for Apple and the market, the benchmark return and the stock return follow each other relatively closely. So in the context of finance, beta measures the sensitivity of the stock's returns compared to, in this case, the S&P 500. So I hope you found this video helpful. I did get a comment from a recent video talking about whether I could perform, I want to say it was a DCF, discount cash flow analysis, and part of that model considers the beta of a stock. So thank you for that comment. I think creating a discount cash flow DCF um, model will be a great way to introduce more fundamental analysis into the channel. So thank you for that comment. And I'm slowly researching how to create a DCF model, and then I'm excited to perform that in Python and share it with you guys. Uh, so since beta was part of that fundamental stock price valuation model, I figured why not make a separate video about betas and alphas. Um, so I hope you enjoyed this video. If you did, please like the video and share it with your friends. I hope these coding videos are helpful for you guys. And make sure to subscribe. I'll be creating more coding videos just like this. And hopefully one day we'll get a discount cash flow tutorial series. I think that'd be super fun. Um, but yeah, if you have any other comments or suggestions or what you'd like to see, uh, let me know and I'll definitely get back to you. I'll try to at least. So, um, all right. Well, thank you for your time. Thank you for coding with me. And check out intrendias.com for free buy and sell signals on your favorite stocks, cryptos, and forex. And I'll paste this code into a Intrendia's blog post for you guys. So if you're in a hurry and you want to copy paste it, go ahead from intrendias.com. So I'll catch you guys later. Have a good one.